Hello, everyone, and welcome to today's LinkedIn session. I hope you are well and managing the hot weather that we are currently having. My name's Aneta Gel, and I am a Quality Operations and Training Manager at Paul R. Palmer Limited. I'm very pleased to have you here with me today. I would like to talk about GMP project management in a more practical way today. This is not a session about the project management theory. It's about what happens when engineering, quality, validation, regulatory expectations, and real project timelines all meet in one place. Many of you will recognize this from your own work. You may be involved in a new facility build, an expansion of an existing facility, a remediation program, or technology transfer, or you simply are part of a project where you can see that the timelines keep moving and slipping. The question we will explore today is simple. Why do GMP projects slip, and what can we do earlier to prevent that happening? Please feel free to add questions or comments in the chat as we go along, and I will come back to it afterwards and respond to you after the webinar. So let's get going. Okay. Before we go into more details about the project management and what causes the slippage, I would like to set 3 points here. And the first one is the peak demand. Across the industry, demand for sterile products, biologics, and advanced therapies continues to grow. When new facilities are being commissioned, existing sites are being expanded, and many organizations are trying to increase the capacity while meeting the higher regulatory expectations. We all know about the revised Annex 1, which is a good example of how expectations continue to develop, particularly around contamination control and sterile manufacturing. The second point I would like to point out is the hard truth, as we call it. And many facilities, they have projects that will finish later than planned, cost more than expected, or reach the handover time with production with compliance gaps that then the operations team has to manage going forward. Sometimes those gaps are obvious before the handover. Sometimes they only become visible during your validation, audit, or at first regulatory inspection. Either way, the impact is real because it affects the regulators, the investors, supply commitments, and ultimately the patients who are waiting for their medicine. The third point that you can see on your screens is the good news. Much of the slippage in projects is predictable, and significant amount of that is preventable. When you look across the project, the same patterns appear again and again, which is unclear scope, weak user requirement specifications, late design changes, underplanned validation, and poor vendor documentation, and a change control that is treated as administration exercise rather than a project backbone. So that means the answer is not simply to ask for the team to work harder. Most project teams are already working extremely hard. The better answer is to plan smarter, make risks visible earlier, and build the GMP discipline into your project before the cost of corrections becomes very high. Let's define what we actually mean by GMP project management in a quick summary next. If you look at the diagram on the slide, you'll see 3 domains, and the role of a GMP project manager that sits right in the intersection of all three. The first domain is the standard project management. If you work with PM frameworks, this will be familiar to you. You've got the scope and schedule, the cost and quality, and risk and communications. These are the disciplines that will apply to any complex project, whether you are building a bridge, launching a new product, or rolling out a software platform. They are the foundation. They matter just as much in our pharma projects as anywhere else. The second domain is GMP obligations. This is the layer that sits on top, and it's what makes our pharmaceutical project different from other projects. ICH Q9 and Q10 for quality risk management and pharmaceutical quality system respectively. UDRALEX Volume 4 in Europe, or 21 CFR 210 and 211 in United States. These aren't just the background documents. They actively shape almost everything we decide, every decisions that we make, what materials we can use, how flows are designed, and what gets documented, and how change is controlled. And then we have the third domain, which is validation lifecycle. And this is the one that many people underestimate. Validation isn't just something that happens at the end of the project. It should run in parallel with your design and construction, because design qualification starts during design and installation qualification runs alongside the construction. By the time you reach the end of your project, validation should be already well underway and not just at the point where you're starting to think about it. I am currently working with a client where we have a project and you can see that they have gaps in their change controls because there's not enough documentation. There are gaps in the documentation for qualification and validation where it all seems to be an afterthought. When it comes to change control, the initial topic is captured in an initial assessment, and the correct actions are proposed as part of that assessment, but they are not reflected in action plan. You don't have a detailed action plan with timelines on the requirements, and the protocols are not checked in time. And then you have missing items that are identified once you're running the validation run. So GMP project management is not engineering with compliance bottled on at the end. It should be compliance that is engineered in from the very first decision, because quality is designed into a project, or should be designed into a project, not inspected afterwards. And if you only remember one thing from today's session, let it be that one, because everything else that we are going to talk about today, the life cycle, the timelines, and where the projects generally slip, all of it flows from that single principle. Okay, and now let's have a look at that in practice. So what makes GMP projects different? As I said previously, validation is part of the project. It's not a phase that follows the project. It's not a department that picks things up after the construction. Validation has its own critical path, so it needs its own resource and its own documentation, and all of it needs to be planned from the start. If you treat validation as something you'll get to later and do not work on the details, you've already put your timeline at risks. And I can see that happening with the client I've mentioned to you. So what I need to do is bring it back to focus, change the mindset, which is not easy, but it is not impossible. The second point I would like to point here is that every design decision must be auditable. And I mean every decision here. Every design choice has to trace back to a quality attribute. And once you've signed off your basis of design, then your change control kicks in, which is the third point here. You cannot swap something out because it's cheaper or quicker. So every change that happens during your project has to be assessed, it has to be documented and approved before it's implemented, because obviously change can happen, but it has to be managed in controlled way. And the fourth point is the one that catches a lot of people out at the end of the project, and that is the dual handover. When the project is done, the project team, hands over to operation and also to regulators. Both parties need to be satisfied, of course, and here is the consequence, that you cannot simply fix it later then without triggering a deviation. And this is why we put so much emphasis on the right first time, why we put so much emphasis in the management of the project as a big change with decided prerequisites, and any change to that must be reviewed, assessed, and documented and approved. It's not because we are perfectionists, but because the cost of doing it twice is genuinely much higher than the cost of doing it carefully and right first time. So let's have a look at the shape of the project itself now. This is the map of a GMP facility project broken down to 8 distinct phases, from the first concept right through the handover. And let's have a look at each briefly. So phase 1 is your concept phase. This is where you start asking the big questions. What market are you serving? What's the scope of your project? Is it even feasible? What's the intended use? Is it viable? Okay, and you are working at a high level at that point. Then you move to phase 2, which is project development. So you've decided your project is feasible in your concept plan. Now you're getting a little bit more concrete. You are choosing a site, you're forming the project team, you're writing the project charter and sorting out the financing. This is where your project is starting to become more real. And then you have the phase 3, where you have the project options. You evaluate alternatives, do code analysis, and make the critical choices about which option you're going to take forward. And then we have the phase 4, which is preliminary design. The technical work starts in earnest here. Okay, and crucially, this is also where your validation activities begin. Phase 5 is your detailed design. Specifications are finalized, the validation master plan is locked down, and the design qualification happens here. Then we move to phase 6, which is bidding, where you send your requests for proposals, you pre-qualify the contractors, and the time discipline really matters here, because any delays here, excuse me, will ripple through everything that follows on. Then we have phase 7, which is construction. And this is the longest phase in end of calendar time, because you have the execution, you have the quality assurance, quality control, and documentation control. And remember here that your commissioning and qualification activities are already starting during this phase. And then the last phase is project turnover or handover, where commissioning and qualification is complete, your SOPs are published, training is delivered, and you can hand over your project to operations. Early decisions lock roughly 80% of your total project cost. So by the time you reach the detailed design, most of the cost of your project is already determined. It's not spent yet, but it's determined. And that means that if you want to influence the cost of your project, you have to do that early. Once you are in construction or you're managing the consequences of the decision that you've made many months before that. So very important point to remember. And with that in mind, let's have a quick look of how long all of this usually takes. The bar on this slide kind of gives you indicative durations of a project for a mid-sized GMP facility. And this could be a small, sterile, fill finish suite, around 60 million euros capital, and it has about 24 to 36 months end to end, the overall project. And the actual timelines, of course, can vary, but I think this is more an illustration that shows you the amount of time each of the parts of the project generally take, and the proportions are what is important here. So the concept and project development together about 3 or 4 months on average, and this is the smallest bar on the slide, but we must not be fooled by that. That doesn't mean that it's the least important part of the project. These are the months where most consequential decisions are made. And of course, this phase could be happening way before it is recognized as a concept and project development. So be very aware of this one. Then you have the preliminary phase and detailed design, where generally they take about 8 to 10 months on average. And this is where your technical detail and the validation framework gets defined. Your URS, your equipment specifications, and your validation master plans are happening in this phase where they are being defined. Then you move to procurement and control, construction, 12 to 15 months, the biggest single block here. And inside this period, your long lead items need to be ordered, your contractors need to be on site, and your commissioning team needs to be ramping up at that point. And then we have the commissioning and qualification and validation phases, which are about 6 to 9 months again on average. And this overlaps with the tail of your construction, because as I said earlier, validation doesn't start when construction ends, it runs alongside it. I would like to point out here one important caveat, that these are ranges, they are not promises, and modality of the project will change everything. A potent oral solid dose facility will have a different shape from a GMP facility. A brownfield project will be completely different to a greenfield. Okay, so treat these numbers as an order of magnitude, not as a benchmark to hold yourself to. And speaking of validation, now let's have a look at that in a little bit more detail, because that's the one that catches a lot of the teams out. So the hidden timeline of validation. It may be surprising to hear that the 5 to 15% of the typical share of the total installed cost on a project is consumed by a validation in a GMP facility project. So if we have on 60 million euro facility project, that's 3 to 9 million euros just for validation. And that is a lot of money. And then you have the timeline implication. Validation typically takes 3 to 10 months of the project, but this is not the critical point here, because the validation doesn't start at the end. As I've said, it starts conceptually at the design qualification. during the design phase, long before you get to construction and the completion of it. The chain is, as we know, design qualification, IQ, then OQ, and then PQ, and then process validation. Each of these phases has its own documentation, its own evidence requirement, and its own approval cycles. If you only start thinking about this process, the validation, when the building is finished, you've lost months. So the takeaway here is straightforward. Plan validation as a parallel work stream from the very beginning. Give it its own critical path. Give it its own place in your action plan. If you can, give it visibility in your project KPIs so it doesn't get forgotten. And of course, think about it that it should have its own resource budget. The teams that will do this consistently are the ones that will launch their projects in time. The teams that don't are the ones that will quietly start slipping to 3, 6, sometimes even 9 months, and only realize it when the qualification activities pile up at the end. And of course, what happens at the end? People are pushed to sign whatever is available to secure the deadlines, and then the operations staff will carry the consequences of these gaps. And when the contractors are gone, the consultants are gone, and they are left to run it themselves. Now, the validation is not the only place where the project slips. It's considered one of the main ones, but not the only one. So let's have a look at some other areas where projects can slip. Here you have 5 issues that I see again and again that cause slippages in projects in general. It's actually quite encouraging to say that we see those 5 in almost every project, because it shows us that there is a pattern, it repeats, and then we can put a preventive action in to stop that repeat. So that is a good point. So the first slippage is uncontrolled scope movement after you've set your design. So you've got uncontrolled URS changes. Someone has a brilliant idea, or operations change their mind about the through output, or marketing decides that they need a second product on the line. And each individual change may feel small at the time. When the small changes accumulate, they may disrupt your layout, your utilities, your validations, and the overall schedule. The second slippage is related to late commitment to a long lead equipment like filling lines, isolators, WFI stills, and things like that. Because these items have long lead times between 9, 12, sometimes to 18 months if you're going to order that piece of kit for it to arrive. And if you wait until every detailed design is fully complete before ordering, you are committing to a late delivery. For example, if you're filling line order, you must decide, of course, on the critical parameters before ordering, like what product type you're going to run on it, what container format, the output and throughput, the batch size range, and sterility strategy if needed, your containment requirements, just to mention a few. And that cannot be decided later. That has to be decided and said before you make the order. But what can be decided later, and you don't have to wait for that, is what is your final HMI screen going to look out, the final layout? What is going to be the exact alarm wording, the final recipe names, the final batch format, or the exact locations of some of the local instruments that will be connected to your line. So you don't have to wait for these things. before you make the order. But of course, the critical parameters need to be set before the order is made. Then we have the third slippage area, which is where validation is underestimated and kind of backloaded. And I've covered this on the previous slide, and I've mentioned it a couple of times. But of course, I'm going to say it again. If your validation plan only kicks in after your construction, you've designed a delay into your project. And then we have the fourth one, where it's about the vendor and contract coordination gaps. Because delays often occur when the suppliers or contractors and package owners are not properly aligned. One vendor may arrive before the area is ready. Another one may be waiting for the information from the previous constructor, or the two equipment packages may have specifications that do not align. Documentation, the drawings, the interface details, and any handover information may not move cleanly from one party to the next, and that will cause delays. The fifth area where we see a lot of the slippage is delayed regulatory engagement. And it refers to the surprises that you will have in your pre-approval inspection. And the fix here is very simple and it's very underused. Engage your regulators early. If you engage your regulators early, you will avoid the issues in your pre-approval inspection. So if you notice something about all 5 of these slippages, that they are not technical problems, they are not, they are planning problems, they are communication problems, discipline, documentation problems. And the good news about all this, that because these problems, we know how to solve them. They are not difficult to solve, okay? So before we get to solutions, though, I would like to show you more piece of evidence for why early planning matters so much. So let's have a look at that. And it's very simple. And this is, I think, the chart that probably every project manager should keep in mind, maybe have it on the wall. And that's the cost of change curve, as you can see. And the message is simple. The earlier you find an issue, the cheaper it is to fix. So if you identify a problem at the URS stage, you may only need to amend your requirement and align with the team. Still takes some effort, but it's manageable. If the same issue is found during your detail design, your cost goes up a little bit because you need to change your drawings. Specifications need to be updated and design reviews made to be repeated. So you've got a little increase of your cost there. If the issue is found during constructions, the impact again is much greater. The work may need to stop. The materials may need to be reordered, contractors rescheduled, and the whole set of documentation need to be revised and then reissued. So your cost then jumps up quite significantly. If the issue is found after qualification, the same correction will become much more complex. You may be dealing with deviations, requalifications, validation impact assessment, SOP changes, retraining, and potentially regulatory implications. But the issue itself, it's still the same issue. It's the timing when you identify that issue that will change everything when it comes to your project and the project cost. This is why URS quality, early design reviews, risk assessment, and change control, content detail, and a GMP coordination are so valuable here. They're not theoretical exercises. They are there for a reason, and they are some of the best ways to protect your project timeline and your budget. So let's now have a look at the practical solutions, how you can avoid your slippages. So let's have a look at the 5 main actions that I can offer here to protect your timeline. And the first one, or number 1, is invest time in a URS quality before detailed design begins. I cannot stress this enough. The hours you spend on the URS are the best spent hours of the entire project. A good URS is testable. Its requirement is traceable through design, qualification, and validation testing. If your URS is vague, every later phase will pay for that vagueness. Specify what is the specific equipment requirement. What level of specific range control is it capable of? What system does it need to be compatible with? So you don't have to do the expensive workarounds or replacements later. Number 2, identify your long lead time items. Cover the obtaining of the new piece of equipment and the change control, not under heroic act of expediting it. The discipline is to map the long lead times clearly, decide which ones you can commit to, and order them with the same formal change control as any other major decision. Okay, use the change control structure, the actions to your advantage, so you don't have to remember everything. You write all your actions down with the timelines, and the ownership is important here. So use the change control to your advantage. Number 3, run validation as a parallel work stream, not as a closing phase. Give it its own project a lead if you can. Give it its own line in your schedule. Have a specific action in your change control, not summary one that we see so often. Confirm validation is performed, because that statement is just what does it say? Give it its own specific actions, clear and detailed. Give it its own KPI, so it's checked. Make it visible from day one. Number 4, treat change control as a leadership tool, not as a nuisance paperwork. And this is a mindset, a shift that needs to happen, because change control is not bureaucracy. It's a map that the implementation of your project contain, and it makes sure that all your key details are in, and then you can fall back on your change control during questions in inspections. Number 5, engage regulators early. Pre-submission meetings are there for a reason, and they will shorten your approval timelines. If you start speaking with them early, that will help you to move forward faster. There's no benefit to surprising your regulator. Bring them along, bring them on board so they know what's happening. Now, as you can see, none of these points are revolutionary. None of them require new technology, new software, or extra budget. What they do require is discipline, communication, and a willingness to spend time on planning when the pressure starts building. The willingness to spend time on writing that URS, on putting that specific detail into that change control for the new kit or the new piece of equipment. Remember, you will not remember it all. So document your action, use the change control, use the URS to your advantage. Before we move to the final close of today's session, I want to bring all the points that I've talked about together. And what are they? So the first one, or the first key takeaway, is that the GMP project management means your engineering, your compliance, The validations are run as one integrated system. They cannot be planned in isolation because the decisions in one create consequences in the others. The second takeaway of today is that realistic timelines do matter. Remember, a mid-sized GMP facility will take somewhere between 24 to 36 months end to end. Don't expect it to happen before that, because that would mean you are cutting something important, you are making shortcuts. Of course, every project is different, but if the timeline compresses the design, procurement or constructions, something will happen and you will have issues at the end. The third takeaway is that the validation is parallel work stream. It can represent a significant share of cost and it can drive a critical path if it's not planned early. Validation should influence your requirements, your design, your supplier documentation, even your commissioning strategy and your operational readiness. Think about it early, not at the end. The fourth takeaway is that slippage is often predictable and most of it is preventable. The familiar causes are late decisions, unclear scope, weak interfaces, vendor delays, incomplete documentation, and poor change control. So my call to action is very practical. Pick one of these from today and apply it to your next project or even to a project you run in already. It might be strengthen your URS reviews if you can still do it. If not, do it for your new project. Integrate your validation earlier. Improve your long lead time tracking or tighten your change control process. Start with one improvement and document what changes and then share that with your team. For me, I would definitely go for the change control process and apply it in practice because that would eliminate many issues that, for example, I can see working with a company that I work with now. So that's what I would choose to start today. Okay, so that brings us to the end of my webinar. Thank you very much for joining me today and spending your time on this topic. My aim wasn't to cover everything about project management because, of course, we can't do that in 30 minutes. The aim was to highlight the common pitfalls that the GMP projects have and that create the timeline slips, and to show that many of these pitfalls can be managed with the right structure, discipline, and cross-functional collaboration. If you'd like to explore more about this topic or work on some of the topics that I've mentioned today, like change control, supplier and vendor management, validation, we run courses that you can find on our website, Academy Pharmaceutical Excellence, or contact me directly on anetagel@pqs.ltd. If you want to comment directly, please do so in the webinar and I will come back to your comments. Thank you very much again and have a lovely rest of the summer day. Thank you and bye-bye.